This video would introduce the topic of operator precedence in JavaScript. We would first use a visual metaphor to illustrate how precedence can be visualized in terms of operators being placed on shelves on different levels. And we would then use a piece of code, break it down, and illustrate how precedence works in practice. We will finish off by discussing how precedence can be thought of as a tree structure, which would help us understand it better under the hood. This is an excerpt from the second part of a course called JavaScript for Visual Learners. If you want to see the first 2 hours of the first part of the course in its entirety, you can follow the link which is included in the description below. You would not be able to get very far when using operators in JavaScript unless you understand well the idea of operator precedence. This is something which we have already mentioned in quite a few places in the course so far. The idea is that different operators would be evaluated in a different order on the same line of code. If we have, for example, a set of parentheses in the code, these would always be evaluated first. Multiplication would always be evaluated before addition, etc., etc. If you want to learn about precedence, it is a good idea to use reference material, and probably the best one to use in this case would be the MDN web docs, and more specifically a table on operator precedence which is available on the website. You can see the link on the screen. To help us visualize things a bit better, what I've done is to use the same table and to build a virtual bookshelf off of the various parameters. The parameters are shown as boxes with handles, and their vertical position on the shelf determines their precedence, i.e. it determines the order in which they would be evaluated on the same line of code. The parameter on the very top of the shelf is the grouping operator that we just discussed in the previous section. The parameter at the very bottom is the comma operator. And then we have the other parameters in between. One very good way to think about parameter precedence is to think about an order in which they are processed. And in this case, the order can use actual numbers. The higher the number, the higher the precedence. So we can think of these numbers as determining the order in which operators are parsed in a line of code. The operators with the highest numbers would be parsed first. Let us use a line of code, and more specifically, let us break down a line of code in its components so that we fully understand how precedence works in JavaScript. In this case, we have 5 minus 2 in parentheses, followed by a minus sign, the subtraction operator, followed by 1, followed by the multiply operator, followed by 5, followed by the exponentiation operator, followed by 2. As you can see, we are using quite a few operators, and the order in which they are evaluated can greatly affect the final result. For example, it makes a very big difference whether exponentiation is done before multiplication, or whether multiplication is done before subtraction, or the other way around. So let us in fact use the numbers from the bookshelves from the previous slide to understand how this code would run. We see a pair of parentheses. We know that these represent the grouping operator, and we know that the precedence of the grouping operator is 21. As we already mentioned, this was the operator at the very top of the bookshelf, the operator with the highest precedence. So in a way, this bit is easy. We will just evaluate the stuff in between the parentheses first. But what about the others? We really have to look them up. We have the exponentiation operator, which occurs on shelf 16. We have the multiply operator, which occurs on shelf 15, below it. And then we have the subtraction operators, which occur on shelf 14. Looking at the numbers in this case, the grouping operator will have the highest precedence at 21, followed by the exponentiation operator at 16, multiplication operator at 15, and finally the subtraction operator at 14. So we can now use these precedence numbers to make a prediction about how the code would be evaluated. What would be the final value of the entire expression? We know that the bit in the parentheses would be evaluated first. So we would have to subtract 2 from 5. To do this, of course, we would have to use the subtraction operator, which is a binary operator, where the left operand would be 5, the right operand would be 2, and we would get a final value of 3. So the final result given to us after using the grouping operator would in fact be the number 3. What would be the next thing we would have to do? Well, we have the exponentiation operator, which has precedence of 16. This one would have to be evaluated next. But what would be its operands? What exactly are we going to input into this binary operator? Well, the answer is that we would have a left operand of 5 and a right operand of 2. What we would do is that we would have 5 raised to the power of 2, which would give us 25. We would in fact be able to fully substitute this part of the expression by the value 25. This would be the result. Okay, so what comes next? Well, next comes the multiplication operator. This one is placed at number 15. We again have to ask ourselves what the operands would be. Well, the left operand would be 1, and the right operand would be, think about it, 25. This is the bit that we've already evaluated. 1 times 25 is equal to 25, so this would be the value that would be evaluated from this entire part of the expression. Okay, so what is left to do? We in fact only have one last bit that we haven't evaluated. It has to do with the subtraction operator at precedence 14. What would be its operands? Well, its left operand would be 3, the result of the parenthesis part of the expression, and its right operand would be 25, the result of evaluating everything to the right of it, 1 times 5 to the power of 2. How much is 3 minus 25? Well, the answer would be minus 22. This is the final result of our expression. Are you noticing something interesting about what we just did? Do you notice that we just built a tree structure? The minus operator is at the very top. You can think of it as the root of the tree. The various operators will then form nodes along the tree. You can think of nodes as the locations where the individual branches meet at a common point. And then the numeric literals would form the leaf nodes of the tree, the branches at which the tree terminates. This would in fact be the same structure that the abstract syntax tree, which would be built based on that code, would look like. We have already discussed abstract syntax trees in a couple of places in the course, so please review these sections if you need a reminder about how they work. The point that I want to make is that the same rules that we discuss when we talk about precedence in a line of code would be the rules that the JavaScript engine would use when it's putting together its abstract syntax trees. All of these topics are interlinked, and this is why understanding them at depth is fairly important. Let us finish this section by trying to visualize the same code we've been looking at in terms of the visual models of binary operators that we've been using. As we mentioned before, the bit inside of the parentheses, i.e. the input to the grouping operator, would be evaluated first. We would have a left operand of 5, a right operand of 2, and a result of 3. The second operator that we would use would be the exponentiation operator. This one would have a left operand of 5, a right operand of 2, and a resultant value of 25. Notice that this operator would be forming a different branch of the tree. We would then take the result of the exponentiation operator, 25, and then we would input it as an operand in the multiplication operator. The other operand in this case would be 1. The very last thing that we would do is to take the results of the last two branches of the tree, 3 and 25, and then use them as inputs in a subtraction operator for a final result of minus 22. The great thing is that what we just did is identical to what the JavaScript engine would do when it's evaluating the same code. We have built a tree of linked binary operators. Hopefully precedence is a lot clearer to you now, and hopefully thinking about it both in terms of numbers but also in terms of a tree structure has been useful to understand how everything works in the background.